In this episode, I have a Luxman KX100 Cassette deck. This one's brought in with a couple of different problems. Your initial complaint was just the motorized door wasn't working, but on closer inspection I found, well, it's not working at all. And even after getting that going, I found yet another problem. So we have three separate problems on this one to tackle today. So let's get started. Here we have a Luxman KX100 cassette deck. This is the one that's got the fancy sliding control panel. When you turn it on, it's supposed to go in like that, but it's not. So that's apparently all that's wrong with this, is that it doesn't retract the face so that you can access the controls, like for adjusting the levels and so forth. Now, this is what I've been told is wrong with it, that everything else works. So let's see if everything else does work. I don't see a tape counter lighting up, and I don't see any operation. So I think it's a little bit more than just that. This has actually got a problem. It does not work at all. There's no transport. The only button that operates is the eject. Now, this was brought to me with no screws in it. The screws are in a bag on the top, which tells me that somebody has been into this unit already. So let's pop it off, pop the top off. At least not all the screws have been removed. Looks like there's two screws holding it together. So we'll remove the two remaining screws and get into this and see what's going on with the mechanism on this one. Gotta like the mechanism here. Little motor through a gearbox that draws this in, and there's a little switch on here which indicates when it's in all the way to stop the motor from pulling, and then when it shuts off, little flywheel here to slow down. Nothing like good old mechanical dampening. The fact that this thing's not running at all tells me that we probably have a power supply problem, because the motor, nothing is turning. So the first thing I need to check on this is whether the regulators are working. Regulators being down here. Just checking to see that everything's plugged in. So say someone's obviously been into this, because most of the screws were missing. But these tape decks, as you can see, were relatively empty. There's nothing real magical about these units. It's just a standard two-head, I think it's a two-head deck. Yeah, this is just a standard two-head cassette deck. Nothing real special about them. Basic, regular, normal mechanism like everybody else uses. And single board design. They have the volume controls and tape selector and so forth on a separate board, which is plugged into the main board. But nothing really that special on this other than this mechanical dampener for that mechanism. But let's check the voltages here first and see whether we have our voltages. There should be probably two different power supplies, I'm thinking. Now, like all good electronics, this one features a removable bottom, which is nice. So let's check the two voltages on the regulators here. We'll ground one side, or one lead of the probe, and we'll look at this one here. There's a 24 and a 12 volt supply. If we look at the board, it's actually marked, so we know what the voltage supply should be here. So this one's the plus 24 supply, and this one here says plus 12. I don't know if you guys can read it, but I certainly can. There it is, plus 12 and plus 24. So these are the two regulators. So on the 24 volt regulator, we have on the, I guess it's emitter collector base, more than likely the basing on this one here. So we have 34 volts, so that's the unregulated. On the base we have 24.9, and we have 25.4, so it's actually probably base collector emitter. Because our base voltage is our reference, that'll be a little higher, so 25.4 and 24.9. This is our output, and this marked here This is our 24 volt test point. You see, this one's here, a 12 volt test point here, and we have 0. What do we have going into the 12 volt? We have 17 volts, and what do we have on the base? We have 0. Okay, so the reason that this one's not working is because we have no bias. This should be a resistor here, and this is probably a 12 volt Zener diode. And I bet you either that resistor is open or that Zener diode is shorted, or possibly this capacitor here. I think that's a capacitor is shorted. So we'll just measure. We'll go into diode test mode first, and we'll measure to see if the Zener is shorted. Looks like either the Zener or the capacitor is shorted. I'm gonna guess that's a Zener. I haven't even looked on the top. Let's turn it around and take a look and see. Is it a Zener diode? And it is going to indeed be a Zener diode. And it looks like it's got covered with that that crappy glue. Okay, I believe this is it right here. There's another Zener over there, but I think it's that one right down there. The other one was, where was the other one? It was over here, I think. Anyway, yeah, that Zener looks like it's cooked. That one right there. Let's remove it and check it out. But I think it's probably just a shorted Zener. Could be this cap too. So I told you there would be a cap across it. It could be a shorted cap. Very unlikely that a capacitor will short. More than likely the Zener. So let's just disconnect it and confirm. Yeah. I know. I probably just amazed some people how I could go right to the first part and check the first part, and people will wonder, how did I know that? Well, it's called knowing how things are designed. I've been doing this long enough that even though I've never seen one of these ones before, the circuitry is all very similar. My iron is not quite up to temperature yet, so it's taking its time to melt that solder. Okay, that one is disconnected. Now we can measure across the Zener and see whether the short is in the diode itself or whether it's somewhere else. Yeah, the Zener diode came out in pieces. It's the Zener. It's the Zener shorted. When I unsoldered the one side, the glass was actually broken on it, and it actually came apart. So that was the problem. So let's go find a new 12 volt Zener. Now, I don't have a 12 volt Zener, so I'm going to make one up by putting a 3 and a 9 together. How we can confirm our voltage here, I've got a 3 volt and a 9 volt Zener diode. And all we need to do, if we want to test this to confirm our voltage, I'm using a 100K resistor in series with the positive terminal going to the cathode of the Zener, and the negative terminal to the anode. Obviously you need a drop resistor here, otherwise you're going to blow it up. My power supply is set to 25 volts as my input, and if I measure across here, I've got 12. I'm measuring across the diode, not the resistor. The input power, as you can see, is 25 volts, and across the diodes themselves, I have 12. So that's my 12 volt Zener that I've just created. Now obviously this resistor is not going to be left in. This is coming out because the resistor is already in the circuit here. But that's how you can make a Zener. If you don't have the exact size, you can use 2 of them, connect them in series, and that'll give you the voltage that you require. So here's my 12 volt Zener. Let's install it, and this should get this unit working. Okay, now we can power this unit up again and check our voltages. So remember, it was our 12 volt supply that we were missing before. We should have our 12 volt supply back, and actually the unit, you should probably hear the motor and stuff start up on it once I power it up. So, got our ground probe on, and I'm on the 12 volt pad right up here. Power. Here we go. 12 volts, 11.5, 11.1, close enough. Our regulation here is 12. So let's see whether this thing will operate. I already know that the motor's coming on because I can see, I don't know if you guys can see it or not, but the capstan motor is spinning. Let's see whether the other devices work. Okay, I can hear that little motor spinning. It's not pulling anything in though. And the counter's lighting up. And the tape type light is lighting up. So that means we have power. When I turn on the power, you hear the motor running, but it's not retracting. It's not operating this cam. How this is moved in is there's a cam gear here that turns to pull the unit in. The motor is certainly spinning. Therefore, there's got to be a belt in there that is that's come off or broken. So let's take the motor off and see. First, we'll clip off the zap tie that holds the wires in place. Therefore, I can remove the motor and just see what's going on. Just a couple Phillips screws hold it in place. Oh, that's how the belt, and the belt is missing. Obviously, that would explain why it's not working. Oh, this is going to be fun to try and get a new belt into that. This is all part of this mechanism. This piece will come off of it, but the problem is getting this thing back together and getting that belt on there. So I'll remove the screws that hold the mechanism on. Because if you notice this thing, the mechanism, it bolts on from one direction, but the motor bolts on from another direction. So this is going to be an interesting one to try and get this piece out of here. Let's turn it up.
Now, I was hoping that there was going to be an easier way to change this belt, but unfortunately, the way that unit is designed, I got to tear the whole thing apart to get at it. Because that belt is wrapped around a pulley on the other side, and there's gears in there and so forth. So this whole mechanism is going to have to be taken apart, which starts out by taking the faceplate off and taking the meters and everything apart to get at it. Once you do that, it's actually not that bad.
Yes, I have to do this the hard way because I can't get at the belt this way, so I got to pull the front face off to get at the screws in behind it, in behind the front face, to remove the bracket so that I can change the stupid belt. A ridiculous design, if you ask me. 2 more screws here on the bottom that hold this front face on so that I can get the one screw I need basically to take out to remove the mechanism. Okay, this will come off now. Should come off just like that. And once that is out of the way, there are 2 screws through here that I can, I think this one, well, I gotta take this off too. I gotta take this piece off, and then there's a hole in behind here that I can then remove the mechanism. I'm gonna remove this other black plate here, all while my power button's just hanging there. Get that out of the way if I can. Now this comes off with the meters. Should go. Gotta cut a wire tie there. Now that the front face is disconnected, I should be able to remove these screws on the back and lift the mechanism out. I think it'll all lift out as one assembly now. And that comes off. And what else is holding this in place here? One screw in the front is holding this in place. It's one big screw that goes right into the center shaft here. And then this whole piece lifts out like that. Now I can take this stupid thing apart and change that belt. Okay, now I can work on this. A lot of work just to get that mechanism out. Kind of a stupid design that Luxman had on their 100 and 102 series. The 102 being the 3-head version of the same deck. It was I think it was a 102 that I last saw back when I worked in the business. And we tore it all down like this. I was just hoping that there would have been an easier way to get into this thing, because it's a lot of work. It's a lot of work just to get this gearbox apart so that I can change a belt. Ultimately, it's just this one screw is the one that I couldn't get out without taking this whole thing apart. So it will. I just have to push this in. And then it comes out just like that. Okay, now that I've got this apart, I can actually pull this gearbox right apart and put the stupid belt back on. We'll mount the motor back in here again. It's got a little planetary gear set on it. Let's say it's a stupid design. I forgot how much work this thing was. It was my assistant that would have done this when I worked at the shop. He would have done this thing. Okay, that's got that assembly back together. Yeah, a lot of work just for changing out that one little piece, wasn't it? Now to remount the mechanism. There we go. Okay. Screws to go on the top there. It was these ones that went in here. Got to plug in the motor. When I turn on power. Cool, huh? So I got a couple blown out light bulbs on here. That mechanism's cool. Yeah, it works. So there's that cam, brass cam. When you turn it on, and then the switch signals it to stop turning, and it locks it there until you release the power. And then when you release the power, it kicks it just a little bit more, just to go past that. So what it's doing is it charges up. I think it charges up a capacitor down over here in the circuit down here. I believe it's right down here, if I'm not mistaken. There's a capacitor down there. It's like 1,000 microfarad at 16 volt, and that charges up when this switch. The switch applies power to the motor when you turn on the power, and then once it finishes its loading cycle, the switch opens and shuts power off to the motor and dumps the voltage into that capacitor. And then when the power gets shut off, it dumps the power back to the motor and kicks the motor slightly to advance the cam a little bit. I think that's how it works. I'd have to actually look at the manual, but I'm pretty sure I remember seeing something like that in the manual. If you guys wanted to chase electrons, here is the circuit right here that controls that operation. So when the unit has got power applied to it, you'll look at the motor here. One side is connected directly to, where are we here? One side of the motor here, it's connected to power. And the other side of the motor goes through the switch to ground. When the unit finishes its loading cycle, this switch switches over to here, which disconnects this side of the motor and puts the motor onto the collector of Q433. A capacitor I was talking about here, it's charged, and this transistor is kept switched on, which keeps 12 volts going to both sides of the motor, right? Because the switch is switched over here. This transistor is on, and essentially keeps the motor shorted. You got 12 volts coming in, going into the motor, coming back to this transistor here. So the transistor is kept switched on. When the power gets shut off, the transistor here goes off, and the capacitor, so then when this transistor goes off, this line goes low. Capacitor dumps through the regulator here, because it's just Q632 is just operating as a regulator. There's a Zener diode on there. The transistor turns off. This transistor here is providing power through the motor. It's still going through the switch here, which is still closed on this side, but this transistor has now gone off, which allows it to complete the circuit, which kicks the motor just a little bit to advance that cam past the point where it holds it, and that allows the mechanism, the spring, to return the mechanism. And that's exactly what they're doing. And that was that circuit that I showed you guys, that little capacitor down here, a couple transistors and a capacitor down there. So when the unit is turned on, it operates until this switch hits the closed position. Now what happens there is when that switch activates, it basically puts a short across the motor, because this transistor is on, so it's applying 12 volts to both sides. Right, if we look at it here, this transistor is on. So when the switch closes, it basically puts the motor, it basically puts a short across the motor. It's going to have 12 volts on both sides. It's going to be connected to B+, but it doesn't matter. It throws a short on the motor. And if you know what happens with an electric motor, if you put a load across the motor, it becomes a brake, because the motor is spinning, and when when you short it together, you're going to short out the back EMF that the motor would produce when it's operating as a generator, which is what would happen if you remove the power. If you just remove the power from the motor itself, the motor would slowly spin down. But we want that motor to stop immediately. Otherwise, we're going to miss the end of this travel, and it's going to release the mechanism. So they short that transistor. They turn the transistor on when there's power applied, so that when that mechanical switch switches over, it basically puts a short across the motor, which stops it instantly. And then when the power goes off, that transistor goes off, the capacitor dumps, it kicks enough energy back to the motor just to kick it forward just enough, and releases it. Now you've got a one-way clutch. Those planetary gears that you saw in there, they form a one-way clutch, so that it doesn't actually drag against the mechanism when it's closing. So there it is. The switch stops right there, stops it dead, and then it just kicks it a little bit. Pretty cool. This thing's got a couple blown lights, and they're going to be 12-volt incandescent bulbs. Well, here's the tape deck with new incandescent bulbs. A little bit different color on these two, just because this one has a blue, like a rubber film on the bulb itself, so that gives this one just a little bit different color. I was going to put LEDs in, but I could not get LEDs that would give me the same level of illumination, so I scrapped the idea of LEDs and went with just incandescent bulbs. So, unit's looking good. Let's give it a test run, see how it sounds. I got all the lights on there so you guys can see the LEDs, or sorry, so you guys can see the bulbs. First we'll play back. Oh, great. Now we have a transport problem. It's not taking up the tape. What else is going to be wrong with this piece of crap? When the guy gives it to me, he says, oh, only thing that's wrong with it is it doesn't retract. Well, it's a little more than that. Looks like it's not taking up the tape either. Let's just see. Where's the button I gotta push? Yeah, the tape. So now we have a problem with this. If I go into play, the hub is sticking big time. Even on fast forward, it's pretty bad, and I got to pull the deck out on this thing. This thing is just getting more expensive by the minute. The fact that this thing's had so many things, different things wrong with it. This is 3 things if you're keeping count. This is 3 faults. Okay, fault number 1 was the blown Zener diode, so the set wouldn't even power up. Wouldn't even turn on. That was fault number 1. Fault number 2, the mechanism to retract the front panel, and of course the burned out light bulbs. And fault number 3, it has a fault now in the actual mechanism itself. So I think if I just take out these screws, I should be able to pull the mechanism out. There should be 4 screws that I can remove, and this will let me remove the mechanism and see why it's jamming. 2 more screws here to take out this front cover so I can see what's going on behind the cover and see why the reel table is jamming. At least these ones are accessible, unlike some brands that are a real pain in the butt to open up. Oh, there's a bulb on here that's blown too. Well, it's staying blown. I'm not going to bother with that one. Okay. Let's see why this thing is not working. With this out of the way, we can power the unit up and just put it through its paces and see what it's doing. This appears to be sticking. So it's either this gear here or the actual mechanism itself. See, when I take the brakes off, yeah, it's kind of sticking. So we'll take the reel hub off and we're just going to pull this little washer off here on the front. Take the hub apart. Try and do this without losing the little cut washer, because I don't have another one. If I do, I'm kind of screwed. Oh yeah, that's that one. That little wheel there seems like it's turning okay. Yeah, that one's fine. It was just this bearing is all gummed up. You can see it. So we'll get this cleaned up, get some oil in there. That one's turning okay, but I'll probably give that one a drop of oil as well. We're going to put a drop of oil on the shaft here and then put that hub back in place. That's a little better. We're going to do this one as well. Because if one of them is bad, the other one probably isn't far behind. You see how the gunge here in amongst this little brass spring. This is where the oil was all dried up, it was right in the base here. So we'll clear that out. Put that one back together, and I probably should at least put a drop of oil on this other bearing here, even though it's not, even though this one's not showing any signs that it's sticking. It probably wouldn't hurt to just put a bit in there. Of course, this is the photo optical detector that's used to operate the tape counter. There's an LED and a photo diode on here, and as this rotates, you see the holes in the gear. That's how it counts the pulses. That's used for the auto stop and for the counter. And I don't want to get any oil on that idler, so I'm just going to use a screwdriver to put a bit on here. We'll get some into that, into the bearing here. That should go down into the bearing, no problem. And then I'm going to soak up any excess, just so that it doesn't contaminate anything else. Okay, that should make this work. We can test it. I turn on the power. Okay, play. Here's play. Fast forward. Rewind. Lots of torque now. Put the cassette back plate back in. It clips into a couple little clips on the side here, on the bottom. There, just like that. do a test recording on this now. So rewind it. And we'll set our record levels. Record and pause. Okay, we'll cue it, and we'll record this with Dolby C noise reduction. And my tape counter, I reset this thing. Counter clear, there we go. Oh, record mute, that button's stuck. Better make sure that button's not stuck, or we won't be recording anything. Better? Okay. Okay, we're ready to roll. Okay, tape's rewound. Let's see how it sounds. There it is. Okay, this one's fixed. And all I gotta do is put the top on it now and get this one out of here. This one, to say, was a lot more work, and there was 3 problems with it. One, the power supply was dead, for starters. We had that problem with the mechanism over here. Oh, and a couple burned out light bulbs, but that wasn't a difficult part. The mechanism here, that piece, that was the fun. Getting that thing working. And then, of course, the surprise that I was not expecting was the gummed up tape hubs. Got everything working. This one's ready to go. Thanks for watching. If you like this content, be sure to hit that subscribe button and you'll be notified of all my new videos. And if you like what you see and you want to support my channel, you can do so either through PayPal or Patreon. The PayPal address was scrolling in the background during the video there. If you want to do it that way, whatever. We'll catch you in the next one. Bye for now.